Hi guys, welcome back to the NLP Part 5 lecture. Let's move on and talk about the pipeline feature. Once again, the purpose of the pipeline is to assemble several steps that can be cross-validated together while setting different parameters. We can set up all the transformation we did during the text processing in a single unit using pipeline feature of the Scikit-learn. So rather than doing all steps one by one, we can then call that single unit for our data processing. Let's see how this will work on our dataset. So to move on, let's do train test split on our raw data again. So our X is going to be df SMS column and our Y is going to be df target column. So this is our raw data, SMS column and target column. And let's run this cell and do the train test split again. So train test split, press Shift Tab, move down and copy the code to save some typing. And this one here. Let's do some adjustments. And now leave the test size equal to 0.33 and random state equal to 0.42 and run this cell. Let's add few cells. And now we have splitted raw data into train and test datasets. So moving forward, let's create a pipeline now. To do this, we need to do another import, which is pipeline from Scikit-learn. So the import is going to be from sklearn dot pipeline import pipeline and run this cell. So pipeline is going to be pipeline with capital P, and if you press Shift Tab, you need to pass in the steps you want. Pipeline of transforms with final estimator. Sequentially apply a list of transforms and a final estimator. So we need to pass in steps in the list here. So the steps are going to be tokenization, computing TF-IDF, and then naive Bayes classifier to train TF-IDF vectors. So the first step is tokenization using sklearn's count vectorizer. So bag of word BOW is going to be count vectorizer, and we passed in analyzer, which was our custom function. Analyzer is process text. The second step is computing TF-IDF, which is actually weighted score. So this is going to be TF-IDF and then TF-IDF transformer. The next one we want to do is we want to train our classifier. So the classifier was naive Bayes classifier to train on TF-IDF vectors. So on these vectors. So NB model, and which was multi-nomial NB. And let's run this cell. So this is our pipeline. What this pipeline is doing, this pipeline is going to perform 3 steps. One, bag of word using count vectorizer, and the analyzer is our custom function. The second one, computing TF-IDF using TF-IDF transformer. And the third one, naive Bayes classifier to train on TF-IDF vectors, which is NB underscore model and the multinomial NB. So let's add few cells. Training and predictions using pipeline is similar to any of the machine learning algorithm. So for training purpose, we can call pipeline.fit and then pass in x train and y train. And let's run this cell. It may take some time because it's computing these three steps. And we are passing the raw data here. So this one is our trained model. So let's find out the predictions now. So the pred is going to be pipeline dot predict and pass in x test and run this cell. So now we have the predictions, we can do the evaluation. Let's print the classification report and confusion matrix. So print classification report, pass in y test and our pred. And the second one is confusion matrix and pass in the known values, which is y test and the predicted from our model. And let's run this cell. And here we have the classification report and confusion matrix from our model. Once again, the results are quite good. Model is performing very good at the moment. So guys, you realize how easy and convenient it is to use pipeline feature in this case. You are defining all the steps in pipeline and separating the raw data in X and Y, and then using pipeline you're calling fit and predict, where all the steps are happening. At the end, you are printing classification and confusion matrix. The model is doing very good. So guys, excellent work so far. This was a very long lecture. This is why I have split this into 5 parts. I hope you enjoyed working with the dataset in NLP. Natural language processing is a great skill to add into your profile. It is a kind of subfield of machine learning and need practice along with the domain knowledge. However, this is a great skill which is very marketable and easier to get job. It needs hard work and lots of practice. So the key is practice. In this project, I have only used multinomial NB model. Try using other models such as SVM or random forest instead of naive Bayes and compare your results. It is easy. You only need to change the classifier in the pipeline. So instead of multinomial NB, you have to change this to the logistic regression or random forest classifier. Once you change this model to the other model, you can rerun these 2 steps only. If you explore the reference notebook, I have already provided code to use logistic regression classifier where I have changed the model to the logistic regression in the pipeline and rerun the fit and predictions and then printed the confusion matrix and classification report. The code to deploy random forest classifier using pipeline is also provided. If you compare these 2 models, you see that results are quite good. However, random forest classifier is doing better than SVMs. I suggest you guys to do these yourself and try using other models as well. Please note, in the real world data, you will set up the transformation and create such pipelines to make things easier and try different options. This is how the thing works. So guys, this was all about natural language processing using Python. I hope you enjoyed the lecture. See you in the next lecture. Good luck.